Okay. Good morning, all. So far we have covered basically what is a programming language. So programming language is the way we talk to a computer, right? So we have categorized that. Why do we need to talk to computer? I mean, we will be using a very English type language to talk to a computer, but computer does not understand English language. Computer always understands a language which is a language of zeros and ones. We as a human being will issue instruction to the computer in a English type language. Computer does not understand English, right? So we have different types of programming languages. So primarily we can categorize the programming language into two types. One is functional programming language and one is object oriented programming language. What is a functional programming language? A programming, it's basically a style, or I would say a type of programming language in which everything sounds like a verb. So we will be writing only functions and methods. Example of a functional programming language is C, but C had some various shortcomings. Those shortcomings were taken care of object-oriented programming language. Now, what is an object? What is a class? I have explained. I have given several examples of class versus object. So class is something like a template. An object is, I would say, something which is an example based on that template. If I say book, so a book will have certain characteristics. How will you describe a book? So a book will have certain characteristics such as book will have author, book will have index, book will have number of pages, book will have publisher. If I say, can you give me an example of a book? So the answer could be Romeo and Juliet is an example of a book, right? Or maybe The Wings of Fire written by APJ Abdul Kalam, or My Experiments with Truth, which is written by Mahatma Gandhi. So these are examples of a book. So all these books will have certain the same characteristics. Book will have index, book will have author, book will have publisher, book will have a price, but the value of those attributes will be different. Is it making sense to you?
Yeah.
So we understand what is a class, which is what is an object. If I say sports, so what is sports? Sports is a class or an object. So the answer is, how will you describe a sports? So sports will have characteristics. What? How will you describe a sports? So sports will have number of players. Sports will have, I would say, whether it, what kind of equipment or tool it uses. Sports will have whether it indoor sports or outdoor sports. So if I say, so these are the characteristics of a sports. If I say, give me an example of a sports, answer could be cricket is an example of a sports. Hockey is an example of a sport. Soccer is an example of a sport. So all these examples which I said, they are called objects. So they will have the same attributes, but the value of those attributes will be different. For example, if you say hockey, so hockey might have, let's say, 12 players. If I say cricket, cricket has 11 players. If I say chess, so chess also has two players. So chess is an indoor game, hockey is an outdoor game, soccer is an outdoor game. So these are all examples. So, but all these objects will have the same attributes, but the value of those attributes will be different. We all understand this part. Then we said that we have written a program in Java. Can we execute that Java program straight away? The answer is no. There are two steps. First of all, you need to compile that Java program into a language which computer understands. So whenever we write a Java program, it will that file will have an extension called .java file. We have different file extensions, .txt, .doc. In Java, we'll have a .java extension. We convert that .java file into .class file by making use of a compiler, which is called Java C compiler. Right. So once we have compiled it, now we have .class file, which is the binary format which computer can understand. But how does computer will execute that program? In order to execute that program, you need to have some sort of a software available to you, which is called Java Runtime Environment, JRE. How do you get that JRE? You need to install Java on your laptop. How do you install Java on your laptop? You need to go on the Oracle site. I showed you. You need to register there. You need to download the exe file depending on the platform that you have. If you are using a Windows operating system, then you have to download a specific version of Java. If you're using MacBook, then you need to download a specific version of Java, right? So depending on the platform, you have to download it. And then once you have downloaded it, so how do you verify whether Java is installed properly or not? You just have to go on the command prompt and type Java space minus version. And if you're able to see the version, that means Java is installed properly. So far, we have covered this part. I hope it is making sense to you.
Yeah.
Yep. Now we'll start writing the program. So before we write the program, I'll just try to explain how do we write the program, right? So let us understand this. We have not spoken till now how do we write a program. We have been talking only theory part. Let's do something sensible part, right? All nonsense we think in this so far. So let us do something meaningful, right? So how do I write a program in Java, right? As I said that we already understand what exactly is a class, right? What is a class? Class is a template, right? It will have it will specify the attributes. So let us take an example of a normal class. We'll call it as a student class. So I will draw this diagram. So and I said that if two developers have to talk to each other, if they have to communicate how they're going to write the class, they will tell the skeleton. How does the structure of the code will look like? They're not going to write the whole program and then they'll say that this is how my class looks like, isn't it? If you're trying to build an aeroplane, do you build the whole aeroplane and then say to show the customer, see, the aeroplane will look something like this, or you will develop a small prototype. You develop a small model and you'll say this is how the aeroplane is going to look like. If you're going to develop the whole aeroplane and then you say that this is how the aeroplane looks like, then if you have to modify it, it's going to cost you a lot of money. Similarly, when you're trying to develop a software, you don't develop the whole software and then you say to your fellow colleague that this is how the class looks like. You have, before you're trying to develop it, you need to tell how the structure of the code will look like. That communication happens using a programming language, using a language which is called modeling language. Why model? Because it's not the actual class, it's just the model of the class. Is it making sense, Tracy?
Yeah.
That is called a unified modeling language. So how do we represent the class using this UML? We'll draw a rectangle. It will have 3 sections. The first section will have the name of the class. We'll say student. And then student will have some characteristics, attributes, or features. These are all same. Don't try to think anything technical. Just think like a layman. So what are the characteristics of a student? Let's, for the simplicity purpose, we'll take only 2 characteristics. We'll say name and roll number. Right, and student will exhibit some behavior. So behavior means it sounds like a verb. So it's something like an action. So how do we display action or a verb? By making use of method. I'll say read or sleep, and we'll use this parenthesis. What is this parenthesis? It says that I'm able to distinguish between characteristics and a method. So method, we use this is bracket, we call it as a parenthesis. Is this clear to you? Okay, now what do we call? These are called, you can characteristics. We can also say that this is sort of a data. So every class will have 2 things, data and behavior. So data is always stored in attributes and behavior is always exhibited by something called method. Is this clear?
Yeah.
Now, what kind of data? Why are we talking about this data? So we have different. If I ask you few questions and all of you have to answer it. For example, if I say, what is your name? This is first question. If I say, how many members are there in your family? If I say, what is the fuel price? If I say, are you a software engineer? Right? Or if I say that, let's say, yeah, these are the few questions, right? So if I say, what is your name? So your name, you tell me something which sounds like an alphabet group. For example, you'll say, I'm Tracy or I'm Jitendra, right? So what is Jitendra or Tracy? It's a group of characters, a group of some alphabets, isn't it? It's a group of alphabets. Something, you're not going to say, what's your name? Your name is 1, 2, 3. Are you going to say your name is 1, 2, 3? No. You're going to tell something which is a group of sequence of alphabets, some sequence of characters. So you'll say, let's say, Tracy, something like this. If I say, how many members are there in your family? So you're going to tell me some number. Are you going to say 3.5 or 3.2? No, you'll say you have 3 members or some number, 4 members. Or if I say, how many patients died of coronavirus? So you're going to tell some number. You'll not say that 500.5, 500.6. You'll always tell me some sort of a number. So what is this? This is actually what? This is a data. If I say, what is the fuel price today? You will tell me fuel price is what? You say 102.36, isn't it? If I say what is the economy GDP growth rate, 3.5. So you are telling me some has some decimal places. If I say, are you a software engineer? So what will be your answer? Either yes or no, isn't it? So something like this. So you can see here, there is, if you see some pattern in this data, right? So we have different types of data. There's some one category of data which is having answer in yes or no. There's one category of data which is having some numbers which has some decimal places, and one category of data which has only numbers, some whole numbers, 3, 4, 5, 500, 600, and some category of data which has sequence of characters or alphabets, isn't it? So do you, these are all data, different types of data. So in programming language, right, we try to give them a particular category. That how do we categorize that data? We put them into different sections. For example, let's say if you go to any grocery store, let's say if you go to Tesco or Asda or any shopping mall, you'll see that there are different sections. One section will be medicine section. One section will be clothes section. One section will be vegetable section. One section will be snack section. Why do we have these different sections? Because we can logically categorize the items. Do we mix up all of them together in one go? Do you find medicine, clothes, vegetables, snacks, shoes, everything kept in one go, kept in one place? If they keep everything in one place, will you be able to find out? Let's say if you're looking for a medicine, you'll not be able to you'll never be able to find out, because the whole purpose of having these different sections is you're logically trying to group your items. So in a software world, you try to logically categorize your data. Is this making sense to you?
Yeah.
So medicine will always have medicines, clothes will always have clothes, vegetable will always have vegetable, snacks will always have snacks. Why are we organizing it? So that we can store the data efficiently and we can retrieve. We should be able to keep clothes in a clothes section, and we should be able to find clothes section. Imagine if these categories are not there. So if at all you're looking for a cloth, you might end up spending the whole day, because clothes, medicine, vegetable, snacks all are kept in one basket. You will never, you have to take out each and every item. So you'll completely go mad. The whole, I mean, we do this in our daily life also. The whole purpose, I'm trying to explain this with a daily life example so that he can relate it. In software also, we have different categories of data. So we give them particular name. Is this making sense to you?
Yeah.
So certain item might take more space, certain item may take less space. For example, snacks might take less space, vegetable might take more space, because the amount of the kind of object that you're storing, it might need more volume, isn't it? So depending on the kind of item that you're storing, some of them might take less space, some of them might take more space. So similarly in software also, the data type, some of the data type might require more space, some of them might require less space. Is it making sense?
Yeah.
Now we will say that how do we categorize this data? So the way we categorize this data is, I'll just quickly rub this off. So we have different types of data in Java. What is this data? Just a category of data. So first type of data is called, I will say, numeric data. What is numeric data? Which is sounds like a number, right? So one is called bytes, another is called short, another is called int. I'll explain what exactly this byte, short, and int. But these are all basically, I would say, numeric data, which has some sort of a number. Why do we have three types of data? Byte, short, int. So bytes is a type of, I would say, all these are having numbers only, integer type data. Now, what is integer type data? Can you give an example of integer? So 1, 2, 3, 4, these are all examples of integer. Mathematical numbers, we all know by math, we all have studied math. They are all whole numbers. So byte, short, int, etc. and long. Byte, short, int, long. These are four types of data. All of them, they store integer type data. Why do we have four types? If we have just only number type data, then why do we have four different types of data to store these integer type? So the answer to this is, some numbers will be small in size, some numbers will be bigger in size, right? Some of them why I'm talking of size and what is the context of size in case of software. So for example, if you are downloading you have a movie in your laptop, right? So you say that no, it needs a lot of space. But if you have some Word document, it might need less space. So we have a hard disk of certain capacity in a laptop, right? So that memory is finite. You don't have infinite amount of memory. You cannot keep on pouring the data on your laptop. You need certain amount of memory. So whenever you're trying to store some information, it requires some memory. So if you keep on downloading all the videos, at some point of time, your laptop will run out of memory. You cannot store any more data in your laptop. So any programming language also, if you're trying to store some data, it has a finite amount of memory, right? So that memory, basically, whenever you're trying to say that, okay, I'm intending to store a data of particular type, so you need to allocate some memory. You need to give some memory. Okay, this is of this kind of data. It will need this much amount of memory. Is it making sense to you, Tracy?
Yeah.
So to store all the data types, which is of a number type, we have basically 4 categories: byte, short, int, and long. We have 4 types. All of them, they store integer type data. But then why do we have 4 different data types? Because the size may vary. I'll tell you what exactly how this size is decided. But assume that these are these are the 4 data types. It stores only number type data. I'm coming to the size part a little bit later. All of them, they store the data which sounds like a number. What is the example I gave you? That how many members are there in your family? The answer is 4. Or how many friends you have? You'll say I have 5 friends or 6 friends, right? So you're always telling me a number. So that is something which is like a number. So you'll store all that kind of information inside a category which is called byte, short, int, or long. These are 4 types of data. The 4 types of data in Java, right, which stores only integer type data. And why we have 4 different types? Because each of them have a capacity, right? Some of them store a small amount of data, some of them store a large amount of data. Is this clear?
Yeah.
Now, what is the other type? The other type is called numbers with decimal places. Numbers with decimal places. So one type is float and one is double. What is float and double? Again, these are 2 types which stores numbers which have decimal places. Example, I said that if I say that what is the fuel price, you say 102.6. If I say what is the Apple stock price, you will say $500.32. If I say what is the current pound rate, you might say pound to rupee, you'll say 98.32. So you're always telling me a number which has some decimal places. So these are numbers which have some decimal places. So you categorize these data, and there are 2 types of data, float and double, which will store these numbers which are having decimal places. Now again, why do we have 2 types of data? Some of them will store a number to a higher accuracy or up to say more precision. For example, if I say that 30.3658764, and if I say 30.36587412345 that means this one category of data stores number up to higher precision, and this one stores only up to lower precision. Is this making sense to you?
Yeah.
So we have float and double. So double has a higher precision and float has a lower precision. And of course, the size also varies. So we'll see about the size part. Double has a higher capacity as compared to float. Is this making sense to you, Tracy?
Yeah.
100%?
Yeah, it does.
Jitendra, is it making sense to you?
Yeah.
So far what we have seen is we have tried to categorize the data. So we have seen so far 2 types of data, the numbers which are whole numbers and the numbers which are having some decimal places. The third type is, I would say, something called, we call it as which results in yes or no kind of answer, right? So in programming language, there's nothing called yes or no, we call it true or false, right? We don't use the word yes or no, we say true or false. So that kind of data is called boolean data type. Boolean. And something which always results in form of, I would say, some sequence of characters, right? Where as I say, what is your name? You said Tracy. Where do you stay? You stay in Harrow or a Hounslow. You're telling some group of characters. You don't say I stay at 123. 123 is what? It's a number, right? So whenever you use some characters, that is also called a data type. So that is called basically string data. String is actually not a data type, but for at this point now you have to understand that it's a sort of a data type which stores sequence of characters. Is this clear? Sequence of character, which means I'm talking of more than one character. But let's say there might be some requirement. If I say, what is your gender? You'll say either M or F. So you're using only one sequence, one character. So for that also we have a character type in Java. We call it as a char. Char means only one character. You'll say either, for example, if you say yes, Y, or no. There are some type where you'll say you just write only one word. So that is, if you have just one character, so that data type is called char. Is this making sense to you so far? Tracy?
One character. Yeah.
Are you lost?
No, I'm not lost at all. Just making a difference between boolean and car.
So
yeah.
boolean. So okay. So I boolean always results in two possible outcomes. One is called true, and one is called false.
It's words. Yeah.
If I say, "Are you a contractor?" You'll say false. Are you a permanent employee? You'll say true. So that means something which results only in true or false. Are you a software engineer? The answer is false. Right? Are you a mechanic? The answer is true. So anything which results in only true or false, we try to categorize them and we store them inside a data which you call it as a boolean data. Is this clear?
Yeah.
100% clear to both of you?
Yeah.
Okay. So now this is about data type. So in Java, we have 8 data types. We'll say byte, short, int, long, sorry, byte, short, int. We have something called char. Let me write down here. Byte, short, int, char, int, long, float, double, and boolean. So why do we have these data types and why it has been named like this? Int always, you cannot question. This is something which is predefined, those who have developed this programming language. Int means integer. It always stores integer type data. So int, short, byte, and long. These 4 types are used to store only integer data types. What is char? Char will always store only one alphabet, either A or B or C, just only one alphabet, or Y or N. What is this float type? Float and double, they always store some number with some decimal places. What is boolean? Boolean will have only 2 possible answers, true or false. Is this clear to you?
Yeah.
100% clear?
Yeah.
So this is concept of data types.
So no string is not there.
String is not there. Let me mention it explicitly. String is, you can, for the time being, I'll be using string in all my programs. So you can consider also string also as a data type, but it will be a sequence of characters. Let's say if I say Tracy. So how many characters are there? TRACEY. You have more than one character. So consider string also as a data, but technically speaking, string is not a data type. It's a class in Java, but it will be discussed in future chapters. But just for the ease of understanding, you can assume that it is something, a data type which stores a sequence of characters. Is this clear to you?
Yeah.
So the difference between string and char is only one character and string is a sequence of characters. Is this clear?
Yeah.
100% clear?
Yeah.
Okay. So just one more thing I would like to explain here. We have been talking about, okay, let me tell you the size. What exactly is the size? I'll just briefly, I'll go to the Google and then I'll show you exactly what is the size of data types. If you don't know, I'll type here. You don't use Google, by the way. I'm just telling you. So if I say size of data types in Java, if I type here, you can see here. So, okay. So if something is not clear to ask me, don't Google it. You can see here, these are the data types, right? You can see here byte is 1 byte. Now, what is this byte. What does byte means, right? I'll just briefly tell you. If it is not clear to you, it is not important. So please do not stress and break your head. Okay. So if I take, tell me a 3-digit number. So what are you going to do? You're going to write something like this, right? So if I ask you to give me a 3-digit number, you'll say 101131. So it's a 3-digit number. So in computer, we use the terminology called byte. So computer always understands something which is a multiple of 8. Always computer understands a multiple of 8. So either it will be 8 or 16 or 24 or 32, something like this. So if we have something called, let's say 8, 1, 2, 3, 4, 5, 6, 7, 8. So if you have a number which is up to 8 digits, we call it as a 1 byte. We call it as a 1 byte. If I say, and computer always understands language of ones and zeros. That means computer will always write as a 1, 1, 1, 1, 1, 0, 1, something like this. It'll always be either 1 or 0. It will be a mix of ones, but it cannot use 2 or 3, something like this. Right? So computer always understands language of ones and zeros. Now, what exactly is ones and zeros? If it is not clear to you, that's a topic of completely separate class, separate discussion. We'll discuss it separately. But just understand that what is 1 byte? 1 byte means something which is having 8 digits. I would say 1 byte means I will call it as a 1 bit. I would say one digit means 1 bit. If there are 8 digits, that means I'll call it as 1 byte is equal to 8 bits. Just understand the relationship. 1 byte means a number which is having 8 digits. So I call it as 8 bits. Is this clear to you?
Yeah.
If I say 2 bytes means, that means double of this. It will be how many bits? 16 bits. If I say 4 bytes means 32 bits. Is this clear to you?
Yeah.
If I say 8 bytes means 8 times 8, 64 bits.
Yeah.
So it is quite logical that if I'm saying 16 bits, that means a number, any information which is 16 bits, it will be longer than 8 bits. Isn't it? If I say any data which is stored in 64 bits, it will be longer than 16 bits, it will be longer than 32 bits, it will be longer than 8 bits. So we all understand this.
Yeah.
Yeah. If I say byte, short, int, long, float, double. So these are different data types. So short is 2 bytes. Now what does 2 bytes means? A number which is having 16 bits, 16 digits. Now what does it mean? If you don't understand it, please don't stress. We'll be discussing this separately. But assume that a 16-digit number is something which represents 2 bytes. If I say int is 4 bytes. That means if at all I'm trying to store anything which is of integer type data, computer will allocate a space equivalent to 32 bits, that you can store something which is up to 32 bits. Computer is reserving a memory for you. Is this making sense to you or not?
Yeah.
So computer is allocating some memory. So just consider as a high level overview. You are allocating that, okay, this is the place for keeping books. So your book rack is off, it can store only 10 books. You have a shoe rack can store only 20 shoes, 20 pair of shoes. Similarly, int is a data type for which computer has allocated 4 bytes of memory. That means 32 bits. Now, what exactly is this? How internally computer stores it? It's not a topic of this class. But just assume that whenever I say 8 bits, 16 bits, 32 bits, 64 bits, these are the size, right? So this I'm trying to specify the size. So if you go back to that screen, which I showed you just now, let me go back to the same Google page, search results. Yep. So if you pay attention here, so just see here, byte means 1 byte. 1 byte means any data type which will have 8 digits. That means it's 1 byte. Short is 2 bytes. That means you have to, a computer will allocate a memory equivalent to 16 digits. That will be short type. If I say int means 4 bytes. So from this, you can make out that int is having higher capacity, or it takes more memory as compared to short, and it takes more memory as compared to byte because it is 4 bytes. Similarly, you can see here long takes 8 bytes. That means if you are declaring a data type of a long type, it will be bigger than int, it will be bigger than short, it will be bigger than byte. Is this clear or not?
Yeah.
Now the question is, why do we use long? Why do we use int? So the answer is, if you have to store a very big number, so obviously you'll go for long. You are not going to use for short, because short has only very small capacity. It can store only data up to 2 bytes, but long can store data up to 8 bytes. Is this clear or not?
Yeah.
If you want to store a very short number, are you going to allocate a very big memory? The answer is no. Let's say if you're just 2 members in a house, are you going to go for a 5-bedroom house or just 2-bedroom house? So 2-bedroom house is enough. There is no point taking a 5-bedroom house if you just have 2 members. So if you have a very small number, does it make sense to use a long data type? Answer is no. You will go for a short data type. Isn't it logical?
Mm-hmm.
Tracy, is it making sense to you what I'm trying to say?
Yeah.
So if it's a very large number, then you have to use something called long data. Similarly, if you have a decimal places, which is highly precision, which will say it's a very scientific calculation, you want to store up to, let's say 16 decimal places. So you'll go for something which is called, you can see here, this double. Double stores 8 bytes, and float is also, it stores up to 4 bytes. Both these are used for to store numbers which are having decimal places.
Mm-hmm.
Decimal places like 102.36. If I say 102.36 and if I say 102.361540 something, so this is more accurate as compared to this one, isn't it? Because it is having, after decimal places, I'm storing a large number of information, but all of them, essentially this is more accurate. That means it is storing decimal places up to higher precision. So for that we use double. And if you want to store a number, we don't want to have that much accuracy, so you'll use this float decimal places. Is this making sense to you?
Yeah.
100%.
Mm-hmm.
So we all understand what exactly is a data type in Java. Is this clear or not?
Yeah. So when you say the bytes, you say 1 byte has 8 digits.
Bits.
So the 8 bits. So with 2 bytes, do the bits come together as one as to make 16, or separated 8s and 8s?
When I say short means 2 bytes. That means it's a container which can store something which is up to 16 bytes.
Okay.
If I say long means int means 4 bytes. That means it is allocating a memory which has 32 bits, 32 digits.
Ah, okay.
Okay. Something like, do you have a 2-seater car? So only 2 seats are there. Do you have a 4-seater car? So yes, you have a 4-seater car. Or do you have a bus? Let's say a 16-seater bus. Something like this.
Okay.
Yeah. So if you have only 2 members, are you going to hire the whole bus for you? The answer is no. You can go with a, let's say, maybe a 2-wheeler, right? If you have just 2 seats. But let's say if you have 4 members, you'll go for a 4-seater car. Let's say if you're going with a group of families, that 4-seater car is not enough. You're going to rent a bus for a more capacity, something like that. Is it clear?
Yeah.
So we have understood basically what is the concept of data type. Why do we have data type? Is this clear or not?
Yeah.
Okay, cool. So that's all for this class today. In the next class, we are going to cover what is a method and what is the return type.